moving towards the next part of benzene, that is part 2. In the segment 1, we are going to start the reaction part of benzene. Mostly we will discuss about the electrophilic substitution reaction. Now, electrophilic substitution means what? Let me clear it up first. Electrophilic substitution, that means the substitution done by electron seeking reagent. Substitution by electron seeking reagent. So whenever the substitution is done by, that means substitution of hydrogen present in benzene when replaced by any electrophilic or electron seeking reagent is known as electrophilic substitution reaction. Many of the reaction in case of aromatic compound is belongs in this category, like nitration, we can say halogenation, field cap reactions. Lots of such examples are there. Now we are moving towards how the reaction is happened. Let's see the general mechanism. General mechanism we are going to discuss. At first, different steps are there. The first step, if we consider the reagent, that means first step we can say generation of E plus. E plus can be generated. Let me consider this is the substrate. That means say this is the substrate. It can be generated by this manner. That means one first way it can be generated by this way. That means simple dissociation. Heterolytic dissociation is there. That means this is the electrophilic. Or second way, electrophilic reagent can be generated in presence of catalyst. This is the catalyst. In presence of catalyst, it can prepare by this manner. So whenever this is prepared, then only the reaction can be possible, otherwise not. So electrophilic reagent has been generated over here. Now moving to the second part. Now second part, that means second step. So what is the second step over here? Now whenever it is benzene is there and the electrophilic is there, what will happen over here? Let me consider. That means electron is donated over here. That means electron seeking. That means electron is moving towards the electrophilic reagent. So electron is shifted over here, and what will happen? One electron electrophilic and hydrogen is already over here, and one plus charge will be generated over here. This is the plus charge. The plus charge has been generated over here. This 2 double bond remains unaffected. Now the thing is that whatever this carbocation, this is the carbocation has been prepared. So it is, we can say, benzenium carbocation or cation, we can say benzenium cation, or we can write down that way also. That means it is cyclohexa dienyl cation. We can write down like this way, whatever. So this is the cation has been prepared. Now the thing is that this cation is stabilized by resonance structure, by resonating effect. By resonating effect, this carbocation is stabilized. By resonating effect, it is stabilized. It is stabilized. That means this carbocation form this resonance hybrid, which is known as sigma complex also. This sigma complex. That's why this carbocation becomes stabilized. Now, that third step, after preparation of the carbocation, the next step, what will be the next step over here? That means again it will shift over. That means non-aromatic. This is the non-aromatic structure. Again, it will return back into the aromatic structure. So, how it can be possible over here? So, this will be shifted over here. That means hydrogen is shifted over here. That means hydrogen is liberated as H plus ion. So it becomes like this. So this is the overall, it is a general mechanism I have shown you in case of electrophilic substitution reaction. Now one specific reaction I am showing over here, that is also an electrophilic substitution reaction example. So that is nitration. Very important reaction it is, nitration reaction. Nitration means here E plus, we can say E plus, that means E plus this part is acting as a E plus, that means electrophilic reagent, electron seeking reagent it is. So in this electron seeking reagent, NO2, how NO2 plus is generated. Let me see what are the reagents are required over here and how it can be possible over here. Now the thing is that whenever benzene is react with concentrated nitric acid and sulfuric acid, it can prepare nitrobenzene. That means hydrogen is replaced by NO2 group. Let's see the reaction first. That means whenever benzene is there and concentrated HNO2 is given along with concentrated H2SO4 is there, obviously heat should be there, near about 60 degrees centigrade should be there. Whenever it is given, it can prepare the nitro substituted benzene or nitro derivative of benzene, which is known as nitrobenzene. It is known as nitrobenzene. So nitrobenzene, which is known as nitration. So you have here, we have to remember that introduction of NO2 group means nitration. So whatever the initial compound, we are not bothered about that. The introduction of NO2 group means nitration, we have to remember that. So now the mechanism part, how the mechanism, that means how the reaction is happened over here. That is the most important part. Let me see how the reaction is happened. That is the mechanism part. Let me move to the mechanism part over here. Mechanism of nitration. Here, a vital role is played by H2SO4. How? The thing is that whenever in case of nitration, we have seen nitric acid is used with concentrated sulfuric acid. Now in the first step, this nitric acid when react with H2SO4 forming this electrophilic reagent. That means in absence of sulfuric acid, it cannot prepare this electrophilic reagent. So it is one of the very vital part over here. It can act as a catalyst also. As I shown in the mechanism, general mechanism, dissociation, that means generation of electrophilic reagent can be happen in presence of catalyst or heterolytic dissociation. Here in presence of catalyst. Now what will happen over here? Now then the second step, very simple manner. If we can remember the general mechanism, we can easily find out the answer how the reaction is proceeding over here. So NO2 plus is coming over here. Whenever NO2 plus is coming over here, what will happen? Obviously that means shifting over the pi electron will be shifted over here. The formation of what? Sigma complex, as I have discussed earlier just now. So the compound will be like this. Now this is the sigma complex. Now in the third step, what will happen? In the third step, the sigma complex is a 4 minus in the first step, which has been prepared. That means one hydrogen is shifted over here. That means it will attack over here. That means it will catch this H plus ion and the bond will be shifted in, introduced into the ring. That means it will get back the aromatic structure. That means we are getting back the H2SO4 again. So whatever, so this is the process. That means this is the formation of nitrobenzene. So this is the process mechanism of nitration. Hope that we have understood all the part of nitration.